Okay, so this lesson is on rationalising the denominator. It's an interesting thing is that often us mathematicians, we just want to make things a different way. Now, this is an important skill, but it's not the most important skill. And I'll let you know when to use it and when not to use it, but you've got to know how to do it. It's just in certain situations you have to do it. In other situations you don't have to do it. And if we look at the learning goal, we're going to rationalise, and I'm going to explain what that is, the denominator of a fraction by multiplying the fraction by a strategic surd. That's the best way. So we're going to have to multiply it. Best way to explain this is with an example. Okay, so this is an interesting one. You'll come across this one all the time, especially when we do trig. And we get 1 over root 2 from special triangles. I'm not going to go into that now. But to rationalise the denominator, the strategic surd that I'm going to multiply by is root 2, and you should too, by root 2. So essentially we're multiplying by 1, but it's going to get rid of the irrational number in the bottom. Now, an irrational number, pi is an irrational number, root 2, root 3 are irrational numbers. They're ones that if you put in the calculator, they've got a whole heap of decimals, and they never, they never run out. They go to infinity. You can never put them in a nice package. Rational numbers are numbers like 1, 2, 3, 4, but also numbers like a half, 3/5, things that we can neatly package. Okay? There's no way of putting pi in a fraction. There's no way of putting root 2 in a fraction. There's no way of putting root 3 in a fraction. Okay? So when it says we're going to rationalise the denominator, is that we need the denominator not to be a square root, essentially. If we had pi at the bottom, it'd be the same thing as well, but we're not going to work with pi with this skill. Okay, so that's an important thing that I needed to explain. So let's do this fraction. Remember when we multiply fractions, we multiply top with top. So we get root 2 and bottom with bottom. And so we get 2. And done. We've rationalised the denominator. The denominator's here. It's not an irrational number like it was before. Okay, so that's something we can do. Oh, can I just explain something else? If I just wipe this away, I apologise. You might need to rewind if you need to. If this was 2 root 2, you still multiply it just by root 2. Because that gets root 2, and that becomes 2 times 2, because we multiply the root 2's together. So we end up with root 2 over 4. So just something to note about. Okay, let's do this one. Okay, now this is where it becomes really important. What we're going to do is we're going to multiply top and bottom by the same thing, except we're going to multiply by this thing that I've got highlighted, except it's going to be the opposite sign in the middle. So it's going to be 3 plus root 3. And then we're still multiplying by 1 like we did last time. So it has to be the same thing at the bottom, 3 plus root 3. And I don't know why I did that there. I need to erase this equal sign. It's a times that we're doing. And now we're just going to ski jump. So I'm just going to write all my working out. You don't have to do this. I just want to explain what we're doing. And then at the bottom, we've got this times this. So 3 minus 3, 3 plus root 3. Okay. Now, from the bottom, you can see that's difference of squares, because see how that's a negative and that's a positive. But if you don't get it, you can always FOIL it. Okay, so whichever one suits you. But I'm going to just difference of squares, the bottom. But let's do the top. So we'll ski jump this with this and this with this. So we get 6 plus 2 root 3. And in the bottom, we're going to have 3 squared, which is 9, minus root 3 squared, which is just 3. So that means I'm going to go across, but I don't want you ever to go across with your working out. It's going to be 6 plus 2 root 3 over 6. Okay. Now we can take a common factor out of this and simplify it further. Or I'm just going to keep going across. I really apologise. Let's take out 2 from the top, and we've got 3 plus root 3 over 6. And then I can simplify this down. Take that out, take that, 3. So we're left with 3 plus root 3 over 3. Okay? And notice we have a rational denominator. Okay? There's no square root in that. Okay? All right, I'm going to rub this off now, so if you need to pause it, because I'm going to answer the last question. Okay, so maybe I get bigger rubber. There we go. Okay, let's do this. So I'm going to do the same thing. I'm going to multiply it by the same thing as the denominator, except it's going to be a plus instead of a minus there. And if it was a plus here, then I'll be multiplying by a minus. Okay. All right, so I'm going to go 2 root 2 plus root 3 over the same thing. 2 root 2 plus root 3. I'm going to rewrite that as 1 times 2 root 2 plus root 3. That helps us out a lot. And in the bottom, I'm going to go that times that. So it's going to be 2 root 2 minus root 3. 2 root 2 plus root 3. Now, once again, we have a situation of difference of squares. You can do FOIL, remember, if you wanted to. So that's going to be 4 times 2 will be the first term, because it'll be 2 squared, and then it'll be root 2 squared as well. And then the second part will be minus root 3 squared, which is just 3. Okay, so that means it's going to be 2 root 2 plus root 3 over, and that will be 8 minus 3, which is just 5. And that's the end of our answer. All right, I hope this all makes sense. Just do it one step at a time. And remember, if you wanted to FOIL this bit, remember, first, outers, inners, last, you'll get to the same answer. All right, that's the end of the lesson. Peace out.